Welcome back. So in this video, we're going to talk about Chapter 11. Chapter 11 is all about structured data, and we're going to jump in that. And in fact, one of the things that you're going to start recognizing out of the gate when you are now, as we're going forward, is that we're going to deal with a lot of object-oriented programming. Now, at its core, C++ is not known as an object-oriented programming language. And that's because it doesn't do anything like C# and Java. Those are known as true object-oriented languages because everything starts as a class. Everything is a class. Even your main function is within a class. Here in C++, you can actually write code that's not in a class. So that means that the language itself is not a true object-oriented language. However, in most implementations of what you're going to develop for organizations and so forth and so on, other organizations, what people are doing for them, most of the time C++ is written in an object-oriented fashion. So with that being said, you're going to come across a lot of the OOP terms. And so some of them we're going to discuss. In fact, at some point in the semester, you actually have a discussion thread that's all about object orientation and the pillars of object orientation. So as we jump in, start making sure you're taking some notes on object orientation, especially the keywords. You want to understand that. And one of the biggest reasons is when you start to go and interview for a programming job, they're going to ask you to tell them about object orientation. Why do we do object orientation? What's the benefits? And give them some of the terms that you should know as an object-oriented programmer. So one of those is abstract data. Now, abstract data is oftentimes confused with encapsulation. And while they have some similarities, and maybe even a little cross, they are different. And here in a moment, I'll give you a great example of the differences. So let's jump in and talk about abstract data. And abstract data is definitely a data type that specifies some values that are stored within it, as well as operations that can do things to those values. So a user of an abstract data type does not need to know the implementation of the data type. So how is it doing the thing it's doing? And see, right there is sort of where abstract data and encapsulation starts to get really close to each other. Now, it's obvious that ADTs are created by programmers, and what they're trying to say is you're going to find there's plenty of libraries. In fact, we've used some libraries already. But when it comes to creating data types, we as programmers can create abstract data types. So with abstraction, you have a definition that captures the general characteristics without details. This is a great example. I'm going to give you another one here in a moment, but this one's a great one. So the abstraction of a triangle is a three-sided polygon. Now we know any three-sided polygon is a triangle. No matter what the length sizes are, the angles, its three-sided polygon is a triangle. Now we can get more specific. We can say that the scalene, isosceles, and equilateral. We know those types are triangles, but that's the details. In fact, all of those are known as triangle. Now, equilateral is not the same as isosceles, but they are still the same type when it comes to triangle. Another example is when you go on CarMax to look for a car, and you put in that I'm looking for a car, their search is going to show you all types of cars, usually 2 doors and 4 doors. It'll be a sedan or maybe even a sports car, all those things. But they're not going to show you a truck, or they probably won't show you a minivan or a sports utility vehicle, because they see cars as just that, and they see sports utilities as sports utilities. Even there, sports utilities, there's several makes and models in there, a bunch of them. And those are the details. If you want to abstract it, then you're going to say, hey, I want to see all the SUVs. So that's how abstraction works. Why that is slightly different than encapsulation is encapsulation talks about the hiding of what's going on under the covers. Because again, if you get in a car and you hit the gas pedal and it goes, you don't necessarily care how it's going. You don't care about the pistons and the spark plugs and yada, yada, yada. You don't care about that. You just want, I hit the gas pedal, we go. I hit the brake, we stop. And so that's where you start getting into encapsulation, where abstraction is more about a car can be all these other things. It fits all within these other things. So data type defines the values that can be stored in a variable and the operations that can be performed on it. So let's talk about now how we can combine data into structures. First and foremost, C++ structures are different than other languages' structures. They may be called the same thing. Like I know for a fact that C# has a struct in it, and C++ has a struct in it. There's significant differences between the languages, though. In C#, you can have methods. In C++, a struct is only variables. C++, structs can be put on the stack or on the heap, where in C#, a struct will automatically be on the stack and will never be on the heap. Just some things to keep in mind as you're talking about structs. And if you're talking to fellow colleagues that are in different languages, their struct is probably going to be slightly different than your struct. So how do we define a struct? It's pretty simple. It's this general format. You use the word struct, and you give it its variable name. The struct becomes a variable name. And then you put the type and the field of what you want in your struct. Now again, as I've shown you, you do not have the ability to put methods into your structures here in C++. So here's an example of a struct. We've got the word struct. This is the keyword. We've got the ability to declare a variable, declare it with a variable name. So you'll see that it's student. By the way, something interesting to know is when you are naming structures or classes, we'll get to classes down the road, don't fret, don't worry about that right now. You'll notice that they are also a sort of camel type, but they always start the first letter out capital. And again, this is not something that, like if we made this lowercase student, it would work. But when you get into organizations, they will have best practices, they will have coding standards, and this is typically a pretty common coding standard, is that structs and classes, the first letter is going to be capitalized, whereas when you have variables that are not they're primitives like int, string, short, double, they're going to start with a lowercase and then continue on with the camel case. And here you can have an example. Here's the lowercase, here's the uppercase, and then another uppercase. So there you go. So here's a struct. We've got our brackets to indicate the beginning and the end. We've got the semicolon there. Very nice. This is how you declare a structure. So we went over some of this. We already know that a struct has to have that closing bracket and then a semicolon. Struct names commonly begin with the uppercase letter. We just talked about that. And then you can have multiple fields of same type. You can be in the common separated list. So here we can have string, name, address. This is a pretty common technique. Again, we often as developers like to make things look neat and tidy. So oftentimes we'll do just that there. Struct declaration does not allocate memory or create variables. Something to understand. If you put a complex type inside a struct or inside of a class, and you do not allocate memory for it, then when you make use of it, you have to allocate memory for it then. So to define variables, use structure tags as type, name, student bill. Again, this does not allocate memory for it automatically. All right. On the next video, when we come back, we're going to talk about accessing the structure member. So we are going to talk about, now that we've created this structure, how can we use it in our code? How do we get to those member variables, is what they call them, and the rest of our code. So that's going to be in 11.3. That's the next video. See you there.